Hi everyone. So today I, Saksham Khatwani, along with my teammate Prajakta, will be talking about our project SmartMeet, your AI meeting summarizer and action item assistant. So this stemmed from our both of our experiences in tech industry. We have attended a lot of Scrum calls where essentially the follow-up results in some Jira items creation. So we just wanted to streamline that process. And what we're essentially doing is taking the transcripts of those Scrum meetings and giving it to the LLM model to identify the action items. So the tech stack that we're using for this is we essentially have three main components. One is a web-based UI, which we have developed using React and Material UI. The middleware is built with Spring Boot, and the last LLM layer is built using Python and Vertex AI. So Vertex AI is an offering of the Google Cloud Platform, and what it does is it lets us use models such as Gemini, Flash, and Pro to do some prompting. And they run on the Google Cloud stack, so we don't require any GPU on our end, and it's very convenient to use. Apart from that, we're working with local deployments of Kafka, Zookeeper, and Mongo. So I'll talk a little bit about our prompting strategy. So what we wanted to do was we didn't want to use any like the entire transcript file at once. We essentially split the transcript file into small chunks and gave that to the LLM model. And along with that, we also gave some parameters, as you see here, to make it format the action item correctly so that it looks sort of like a Jira ticket and it follows that convention. And we also give the previous action items list as well so that because it's in chunks, there is a possibility of some duplication. So we just want to prevent that. So now I'll be passing over to Prajakta to talk about our model architecture.
Yeah, hi. So Smart UI is our UI component. We have got two backend services. First is summary generator service, which is our orchestrator service, and we have LLM service. Summary generator being the orchestrator receives an transcript file from UI. It then passes the transcript file. It actually creates chunks first, and it passes those chunks and transcript file back to LLM service using the Kafka as the intermediate layer. Uh, and then we are also creating the Jira ticket, so it also integrates with Jira server in order to create the tickets for every action item. Uh, on the other hand, the LLM service has the responsibility of communicating with the Vertex AI endpoints in order to generate the action items and the summaries. And it also has like both these services are talking to Mongo database, which is our SmartMeet database, which has got two collections. First is action items collections, which stores the action items, and then second collection we have is summaries, a summary collection, which store the summaries. Now I'll be talking about the one of the use case where first user uploads a transcript on the UI, and then that transcript is then passed to the summary generator service. Now summary generator service would split the transcript into chunks. For every chunk, it will store that chunk in Mongo database collection called action items, and it will pass the chunk using the Kafka mechanism to the LLM service. LLM service would pull the chunk from Kafka event. It will call Vertex AI endpoint in order to generate action items. It will store the action items back to Mongo database collection called action items, and it will notify the summary generator service about this the availability of action items using the Kafka mechanism by publishing an event. And summary generators consumer Kafka consumer would have subscribed to that event. Similarly, we also generate the summaries. But instead of passing the whole file, the file ID would be passed in the Kafka event in order to not hit the byte limit of the data, like the data processing. So at this moment, LLM service would again call Vertex AI as another endpoint for summary generation, and it will update the generated summary back to Mongo database collection. Once everything is done, user would see action items and summaries over UI. And if user thinks that everything is good, user can hit the submit button. Also, we are allowing users to update anything if they want, like any of the field, like assignee or anything else. So once the user submits the summary, the final summary and action items, summary generator service would update the latest changes in the respective Mongo collections for action items as well as for summaries. Along with that, now at this point, we are in the state to generate the Jira tickets for respective action items. So summary generator service will call Jira endpoint to create issue for each of the chunk, each of the action item, and then in response we will get the Jira issue URL, which will then be sent back to UI for rendering purpose. Okay, so let's move to the debugging. So we experimented with different LLM models like Llama or Google Flans T5 small model, and also the Google's Vertex AI. But we are going ahead with Vertex AI because we have GCP credits and it's convenient from our point of view, and also from compute side also we because we have credits we can use that. The next thing we did is we have integrated with Jira, so we had to actually play around a bit in order to understand the REST API that Jira is exposing to create an issue and the fields that it requires, like assignee ID or issue ID. We also use different tools for our convenience, like Postman and curl for sending the API request. And we use MongoDB Compass in order to track the collections or the records or documents that are created in those collections. So for UI component testing, we have developed, first of all, UI components using React, and we did testing using the storyboard framework, and we tested the components in isolation. We also did, for every component, we did testing in isolation, even for the backend components like LLM service or summary generator services and their interactions with Mongo database and the Kafka. And we, along with that, we did end-to-end testing using for multiple times in order to see if there are any issues to fix them. And we are using SL4J framework for logging purposes. So we have added logs for debugging side and that are really useful. Now I'll hand over to Saksham for rest of the presentation.
Okay, so I'll be talking a little bit about the workload that our service can handle and the potential bottlenecks. So, given the free tier nature of Vertex AI that we're using, we stuck to the transcripts like of meetings of up to like 7 minutes long, and that essentially results in like 6 to 7 chunks. So those are like the number of simultaneous calls we're making to Vertex, and that is very close to their rate limiting threshold. Um, and yeah, we have two LLM services running in parallel. One is for the summary generation, and another one is for action item generation. And those two are running in parallel. But in action item generation case, because we are passing a previous action item generated list as well, there is a sequential component associated to it. So there is a scope of improvement there, and to improve more on like parallelization there. So yeah, apart from that, on an average, the round trip latency call from UI and back to UI with the results is about 2 to 3 seconds long. So now I'll quickly move over to our UI and I'll give a brief demo about it. So this is what our landing page looks like. And here you can see that we have our Kanban board, and here we have like 46 tickets currently. And here you can see this is our Mongo collections. So currently they're empty, and we'll see how they look like once we've hit upload. So yeah, what we essentially need to do is I have a transcript file here of the meeting. I can upload it. I can hit submit, and the action items and summaries are both then queried, and they are being generated in parallel. So we can see that here, both get generated and both get loaded as they're being generated. So I have the option to sort of do some sort of editing here, and I can do that, and I can hit submit. What it will essentially do is then it will go with this updated result to create the Jira the Jira tickets. So here, if I load the Kanban board, I should be able to see the new tickets being created. So yes, you can see we had 46 tickets before. Now we have 49. And if we go over to Mongo, we have this summary generated and the action items generated as well. So yeah, that was a little bit of an overview of our system. That would be all for us. Thank you so much.